Integral from -4 to 4 of the absolute value of x dx. Well, that is a function absolute value of x which is not elementary. See, it's not just a power function. It's actually a piecewise defined function. It's piecewise elementary function. So, since the absolute value of x is equal to two things, either x if x is greater than or equal to 0, or negative x if x is less than 0. This always confuses people. If x is a negative number, say x is -2, the absolute value of -2 is -2, right? -2 is +2, so the absolute value of -2 is -2, which is 2. Okay. So, since that's the case, the integral from -4 to 4 of x dx, well, one of the rules of definite integration is that you can break up definite integrals into two parts. So, let's break up the integral into a part on the interval -4 to 0 and another part on the interval 0 to 4. On this interval, -4 to 0, the absolute value of x is -x because all of the values of x in this interval are negative, and so we're looking at that description. And on the interval 0 to 4, the absolute value of x is x. Okay, and now we are ready to proceed. That is equal to, now by the fundamental theorem of calculus applied twice, -1/2 x squared evaluated at -4 and 0, and 1/2 x squared evaluated at 0 and 4. Now, going to town evaluating these things, I see that when I put a 0 in, I'm going to get nothing. So I'll just put a 0. And I will subtract this term where I put a 4 in. That will give me a -1/2 4 squared. Okay. I'll add to that 1/2 times 4 squared. Simplifying a bit more, the two negative signs here will destroy each other. This will be a 1/2 times 4 squared is 16. The negatives go away there also, plus a 1/2 times 16, and overall that is a 16. Now, it occurs to me that there's an area interpretation of the definite integral applicable when the function is non-negative, and the absolute value of x, of course, is never a negative number. So, parenthetically, which is, well, the word which is used to make a parenthetical remark, even if it's not in parentheses. It's all right, I don't want to talk about that too much. Which is the area of the shape drawn to the right. All right, now let me draw this shape. I will draw a copy of the plane. And on the interval -4 to 4, let me go ahead and use a color for this. I will draw the absolute value of x. Okay. So the idea is we're integrating from -4 to 4. There's some shape that is bounded by the x-axis, by the graph of the absolute value of x. And let's see, this is the point 44 right here. And this is the point -4, 4. The absolute value of -4 is 4. And you could think of that definite integral as being a limit of sums of rectangles with infinitely many. Right? The limit as n goes to infinity. The limit as the number of rectangles goes to infinity, giving you exactly the area of that shape. Now, it makes sense that the first integral gave me half of 16, half of the area of the whole thing, and the second integral up here gave me half the area of the whole thing. And the first part gave me the area of that, and the second part gave me the area of that. Now, you might be confused and say, but wait a minute, this function, negative x, was negative. No, it's not. Negative x is positive valued on the interval negative 4 to 0. Any number between negative 4 and 0 that you substitute into the expression negative x will give you a positive number. So, one more time again, if you take negative 2, substitute it into negative x, you'll get negative 2, which is positive 2. Okay. Better not forget to put a period mark. I also didn't say, by the fundamental theorem of calculus. I better not pass that chance up. Let's see, here's my block for the diagram. And by the fundamental theorem of calculus, all right, there we go.